Good afternoon. Today we are going to see some questions which are from question bank. Now we will go with both parts. That is, here we will see axial deformation considered, and second part we will consider without axial deformation. Without axial deformation, or we can say neglecting axial deformation. Without means we can say neglecting axial deformation. So now we will go with this. Now we can have this. First we have with axial deformation. So we have 1, 2, 3. Then here we have 4, then 5, and then 6. So we have R equal to 6. So we will have DSE equal to R minus equilibrium equations. R we have 6 minus 3, and that is equal to 3. Now we can have DSI for all beams and one story and number of bays. We have open loop, so we have 0. DSI 0 because we have open loop structure. Then from this we will get value of DS equal to DSE plus DSI, and then we will have this value that is equal to 3 plus 0, and that is equal to 3. Now dk, so with axial deformation, then we can have 3j minus r. Now we have 3 into, we have 3 joints, minus r we have 6. And then we will get it as 9 minus 6. And we have value of dk that is equal to 3. Now what is 3? So we have theta c, this is 1. Then we have second, that is theta e. And third we have delta horizontal at E. So we have these 3. Now we will go neglecting axial deformation. So what we will get now in this case? So now I will change the color in this case. So we have now 2 reactions only. Now we have one reaction that is vertical. Now red you have to consider. And then we have moment 2. Then we have here 1, that is 3. And then here we have 1, 4. So we have R equal to 4. Now equilibrium equation in this case we have 2 only because summation fx is not considered. And then we have DSE equal to R minus equilibrium equations. R we have 4 minus 2, and that is equal to 2. Then DSI we have 0 because again we have open loop. And then from this we will get value DS equal to DSE plus DSI, and that we have 2 plus 0, and that is equal to 2. Now dk in this we have to see actually that we have theta c, this is 1, and then we have theta e. So we have dk that is equal to 2. So this is problem number 14. Now we will go to the next problem. So we have calculate static and kinematic indeterminacy of the beam as shown in figure. Now again we will go with 2. So we will use again same color for axial deformation. So we can say with axial and neglecting axial. Neglecting axial. Now we have, now R we are going to be equal to, now here we have 3, 1, 2, 3. Then we have vertical over here 4. And then we have again 3 over here 1, 2, and then we have 3. So R we have 7. And then equilibrium equations we have 3. Then we have DSE equal to R minus equilibrium equations. So we have 7 minus 3, and that is equal to 4. For all beams, we have DSI 0 because we have open loop structure. Open loop. And then we have DS equal to DSE plus DSI, and that is equal to 4 plus 0, and that is equal to 4. Now dk we have 3j minus r, and then we have 3 into 3 minus 7 equal to 2. Now we have this as theta b1, and second we have delta h at b. So we have these two dk. Now neglecting axial deformation, we will go ds r equal to now, and that is equal to, now we have 2 over here, vertical, horizontal we are neglecting, then we have 1 over here 3, and again 2 over here. So we have total r equal to 5. Equilibrium equations we have 2, and then we will get ds e equal to r minus equilibrium equations equal to 5 minus 2 equal to 3. ds I we have 0, then we have open loop structure, and then we can find ds equal to dse plus dsi, and that we have equal to 3 plus 0 equal to 3, and dk we have 1, and that is theta b, as we are neglecting axial deformation, so delta hb will not be there. So this is problem number 15. Then we will go to problem number 16. Now this is pin jointed structure. And here we do not have with and without axial deformation. The above two structures, these are rigid jointed structure. In case of rigid jointed, we have three displacements. Displacement, that is two linear and one angular. So in case of pin jointed, we have two displacements, only linear, no angular displacement in case of trusses. So in trusses, or I can say better, in pin jointed structures, in pin jointed structures, pin jointed structures, no angular displacement. No angular displacement because members are axial members. Because members are axial. Axial, or members are axially loaded, means we do not have any moment, and as moment is not there, so we do not have angular displacement. Linear displacements are related with forces, angular displacement is related with moment, and in pin jointed we do not have moment, and therefore we have only two displacements which are linear displacement. Now we will go with dse equal to first. Now R we will see first. So we have 2 over here, 1, 2, and then we have 2 over here. So we have total R4. Equilibrium equations we have 3, and therefore we will get dse equal to R minus equilibrium equations 4 minus 3, and that is equal to 1. Now dsi, this is pin jointed, we have formula m minus 2j minus 3. Now m we have, so now this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and then 14. So we have total value of m, that is equal to 14. So I can write here m equal to 14, j equal to, so we have 1, 2, 3, 4, 5, 6, 7, 8. So we have j8. So 14 minus 2 into 8 minus 3. And then we have this value that is equal to 1. And then ds we will get dse plus dsi, and that is equal to dse is 1, dsi is 1, and then we have, so that is equal to 2. So it is indeterminate to degree 2. And then dk, here we have only one formula, 2j minus r, because at each joint we have two displacement, and r we have number of reactions. So 2 into 8 minus r we have 4. So we have this value that is equal to 14. So we have this problem number 17. Then we have next calculate the static and kinematic indeterminacy. And for this structure, so now again we have this as pin jointed structure. Pin jointed structure. In last we will see we have 8 into 2. Sorry, 8 into 2 we have, this is wrong, we have 8 into 2 16 minus 4, and this value is 12 because I have calculated and I have this value as 12. This is question number 16. Now we will go to, this is question number 17, and then we have pin jointed structure. Then we have again two reactions. So other values we have two, correct. Then here we have 2 and 2, 4 we have reactions. So R equal to 4. Then equilibrium equations in pin jointed we have always 3. Number of joints, you can see A, B, C, D, E, F, 6, 7, 8, and then we have 9. So J we have 9. M, so M you can see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So we have M is equal to 16. And then we have ds E equal to R minus equilibrium equations. R we have 4 minus 3 equal to 1. And ds I equal to M minus 2j minus 3. M we have 16 minus 2 into 9, 18 minus 3, 15, and this comes 1. And therefore ds we will get ds E plus ds I, and that is equal to 1 plus 1 equal to 2. And then dk we have 2j minus r, then j we have 9, 2 into 9, r is 4, so 18 minus 4, and we have 40. Then we have next, calculate the static indeterminacy of rigid jointed frame. So now we have again 3, 1, 2, 3. So again 3 over here, 6. Then we have 3 over here, 9. And then we have 3 over here, 12. So we have R equal to 12. Then we have J equal to 4, 5, 6, 7, 8, and 9. J 9. And then we will go with DSE. Now this is a rigid jointed. So DSE equal to R minus equilibrium equations. Here we have always 3 equilibrium equations. So R we have 12 minus 3, and that is equal to 9. Here we have horizontal reactions in frames which we are not considering in beams. Then DSI equal to 3C. So number of cuts, C number of cuts required to make structure open loop. C number of cuts to make structure open loop. To make structure open loop. Open loop means if we will start from one point and we have to come to the same point, we have to retrace the path. So if I will consider this one, and if we will start from G, and if I have to come to G, then I have to retrace the path. Means one C that is sufficient, one cut is sufficient. Therefore, I have DSI equal to 3 into 1 equal to 3. And then we will get DS equal to DSE plus DSI, and that is equal to 9 plus 3, and then we have that is equal to 12. So 9 plus 3 equal to 12. Now dk, Here we do not have any change in axial per dk. So we are with axial. So now in case of axial, we have dk is equal to 3j minus r, and we have 3 into 9 and minus r we have 12, and then we will get 27 minus 12, and we will get this value that is equal to 15. Now then we have second without axial deformation. So we have neglecting axial. Neglecting axial. In friends, there is no change in ds with and without axial deformation. Now here you can see we do not have any displacement. ABCD we have fixed. So we have theta 1, 2, 3, 4, and horizontal displacement at this level delta h1. Then we have theta 5 over here, and then here we have delta h2. So 5 theta and 2 delta. So we have dk value, and that value we will get it as dk, we will get it as 4, 5, 6, and 7. So 7. So we have dk that is equal to 7 in this case. And then we have last problem, that is calculate static and kinematic indeterminacy again of rigid jointed frame. Then we will go with, so DSE and DSI are not going to change again in this. So we have R equal to, now we can have 3 over here, then we can have 2, 5, then 1, 6, then we have 3, 9, then 10, 11, and then here we have 3, 11 and 3, 14, 3, 5, 3, 8, 9, 10, 11, and 3, 14. So R equal to 14. Then J we have, so we have 1, 2, 3, 4, 5, 6. Same, we have 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So we have J17. And then now we have ds E equal to R minus equilibrium equations. R we have 14 equilibrium equation 3, and then ds E we will get 11. DSI, now we have to see how many cuts we require to make open loop. So here we have one cut required, then here we require second cut, and then here we have third cut. And if we will go with these 3 cuts, then we are going to be structure as open loop structure. So we have 3 into 3, and that is equal to 9. And then from this ds equal to dse plus dsi, and that is 11 plus 9, which is equal to 20. Now again we have to go for a dk. So we have first, that is axial deformation consider. We have dk is equal to 3j minus r. We have j for j17 minus r, we have 14. So we have 51 minus 14, and that is equal to 37. And then we have, that is without axial deformation. So we will have neglecting axial, and we have dk is equal to, now we have theta 1, theta 2, I will mention all theta first, theta 3, then we have theta 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 theta. Then here we have delta H1. Then at this level we have delta H2. Every floor level we have here delta H3, and here we have delta H4. So we have 14 thetas and 4 deltas. So we have dk that is equal to 18. So likewise we have to solve the problems which are from unit 1, that is static and kinematic indeterminacy. So we will stop here only. Thank you.